Hi guys, welcome to my YouTube channel. Today we'll look at finding extremum of the functions. Extremum of functions. For example, let's say that we have function f of x, y is equal to x cubed plus y cubed minus 3xy, and we have a condition that x and y must be greater than 0. How to find the extremum of this function? In order to find it, there are necessary conditions of finding extremum of the function of several variables. Firstly, derivative of this function with respect to x and derivative of this function with respect to y must be equal to 0. Okay, let's find derivative of this function with respect to x. Then it will be derivative of x cubed with respect to x will be 3x squared, and derivative of y cubed with respect to x is 0, and derivative of negative 3xy with respect to x will be 3y. I guess you know how to find derivatives. Then it's equal to 0. This is necessary condition. These two are called necessary condition of finding extremum of the function. And derivative of this function with respect to y will be equal to 3y squared minus 3x is equal to 0. Then we get these parts. Then what else we can do here? We just use these two equations in order to find the values of x and y. Let's see. Let's write that. And let's divide both sides of this equation by 3. It will be x squared is equal to y. And in the second equation, place of y, I can write x squared, and it will be 3 times y is x squared, and x squared will be x to the power 4 minus 3x is equal to 0. Let's divide both sides of equation by 3. We'll just get x to the power 4 minus x is equal to 0. And then x times x to the power 3 minus 1 is equal to 0. We get that x is equal to 0, but in our condition x must be greater than 0, then x is equal to 1. 0 is not our solution. Let's look at this part. X cubed is equal to 1. Then it's easy to find that x is equal to 1. Then we found that x is equal to 1. Then we easily can see that if x is 1, then 1 squared is equal to 1, then y is also 1. We found that x is equal to 1, y is equal to 1, then that is our stationary point. Stationary point is also called critical point. We get that 1, 1 is our stationary point. The next step to find extremum of function is just we have to find the second derivative of this function with respect to x and y. Let's find them. Let's clean this part, and I'm going to show you how to find second derivative. As you see that we just found first derivative of this function. Now it is time to find second derivative. This is first derivative, and let's find second derivative, this function with respect to x. And it will be 0x squared, derivative of it with respect to x will be 6x, and derivative of this first derivative of first derivative with respect to y, I mean it's the second derivative, it will be negative 3, and derivative of first derivative of function with respect to y will just be 6y. Okay. Then what else? Why did we find them? It's just because we'll write the values of x, y here, and 6 to the power of, 6 times 1 will be 6, negative 3 is always negative 3, and 6 times y, 6 times 1 will be 6. We just want the second derivative of the function. It is time to make a determinant, and in this determinant, in the first row, I will write the second derivative of function f of x y and f of x y. Second derivative of function with respect to x and second derivative of function with respect to x and y. Then it will be 6 and 3, negative 3. In the second row, I write, let's make clear f x x f x y, and here f y x f y y. We have to find this determinant. If this determinant is greater than 0, then we have extremum points. If this determinant is less than 0, there is no extremum. And third case, if this determinant is equal to 0, then there is a local extremum. In our case, just be negative 3 here and 6. And determinant of it, 36 minus 9 is equal to 27. and 27 is greater than 0. So we just have found that there are extremum points because determinant is greater than 0. Then just we have to find if it is a maximum point or minimum point. In order to be maximum point, second derivative of f of xx and f yy, if they are all if they both greater than 0, then it is minimum point. As you see that 6 is greater than 0 and here 6 also greater than 0, then this is minimum point. If, for example, there can be negative 5, then here, for example, negative 7, then it would be maximum point. But in our task, second derivatives of the functions are greater than 0, then it is minimum point. Then f minimum is equal to, our first function was like this: f is equal to x cubed plus y cubed minus 3xy Let's write our stationary point 1, 1 in our original equation. Then we get that 1 plus 1 minus 3, and that is negative 1. Solution of this task is in this way. Hope you understood. Thank you for watching this video until the end.